This is going to be the last video here. I hope you have enjoyed it so far. Let me just get my desktop here situated. So we have, in the last video, we shown that we prefer to use a definition of inverse document frequency that adds the number 1 to the calculation right over here. And now what I want to do is I want to actually do a query result. So first of all, let's remember that there we go. This one represented the query cat, dog. So now what I want to do is I want to go back and I want to do a query cat, dog on my original documents over here, but in lieu of what we said in video number 2, we've got to come back over here and we've got to change these vectors a little bit because the inverse document frequency here is actually incorrect. Instead of this being a 0, it should be a 1. Instead of this being a 1, it should be a 2. And instead of this being a 2, it should be a 3. So what I'm going to do is I'm going to come over here and pull out my eraser. And I'm going to get rid of that, and that, and that. And we'll erase all of these things. And through the magic of technology, they are gone. And now I'm going to come back over here, and I'm going to make this a 1. I'm going to make that a 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, so what happens here now is that D1 is really 1/2, 2, 3. Okay, and I come down here and D2 now is really 1/3, 2, 0, 3 times 0. D3 and D4 we can both see are the same. They're just going to be 1, 0, 0. So this is going to be 1, 0, 0. And this one down here is going to be 1, 0, 0. I hope you can see that what we've done is in changing the formula that we're using for the inverse document frequency, these documents have changed a bit. Notice, by the way, over here, these two documents look the same, and that might seem a little weird, but if you come back and look at them, what really is the difference between a document that contains just the word cat twice and contains the word cat once? I'm not sure there is much of a difference. So now I want to do a query on cat, dog, and I want to do it with these documents here. So let me just recopy these over again. So I've got the D1, D2, D3, D4. Remember, I should be sticking arrows over these things to indicate that they're vectors. This one was 1, 0, 0. This one was also 1, 0, 0. And D2 was 1/3, 2, 0. And D1 was 1/2, 2, 3. Okay, so what I have to do in this case, I've got 4 calculations. Okay, by the way, I don't know if I formally said this before. We're measuring a similarity between these documents, and very frequently in the literature you'll hear people speak of the cosine similarity. And that's exactly what we're calculating here. Because the number that we're going to be deriving is actually the inverse cosine of the angle between these vectors. So now we have to come over here and we have to speak about the similarity between D1 and DQ. Remember, that is equal to D1 dot DQ over the magnitude of D1 times the magnitude of DQ. So in this case, that is going to equal, so that's going to equal 1, 2, 0 dot 1/2, 2, 3 over the magnitude of 1, 2, 0 times the magnitude of 1/2, 2, 3. And that is equal to, well, 1 times 1/2 is 1/2, and 2 times 2 is 4, and 3 times 0 is 0, and that's over, I'm just going to call it the magnitude of D1, and you'll see where I'm going with this in a second, times the magnitude of DQ. Okay. So in the numerator, I've got 4.5. If I want to do the similarity between D2 and DQ, that is going to equal, okay, D2 is 1/3 2, 0 dot DQ, we said DQ is 1, 2, 0. And that's over the magnitude of D2. We're going to have to figure those out separately. Over the magnitude of DQ. And that's equal to 1/3 plus 4 plus 0 over those magnitudes, D2, DQ. We'll figure those all out later. And again, in the numerator here, I've just got 4 1/3. Then I come over here and I do the similarity between D3 and DQ. And that is going to equal 1, 0, 0 dot 1, 2, 0 over the magnitude of D3 times the magnitude of DQ. And that's equal to 1 times 1 is just 1. 0 times 2 is 0. 0 times 2 is 0. So this is over the magnitude of D3 times the magnitude of DQ. And then finally, the last one we have to do is the similarity between D4 and DQ. And I think you'll remember that D3 and D4 look exactly the same. So this is just going to be 1 over D4 DQ. So now we've got these 4 different numbers. I think we need to go ahead and calculate the different magnitudes. D1 1/2, 2, 3. So it's 1/2 squared plus 2 squared plus 3 squared. And we have to take the square root of that. That's equal That is the length of D1. So that's equal to the square root of, that's 1/4 plus 4 plus 9. 13 is equal to the square root of 13 and 1/4. The length of D2 is equal to, D2 is 1/3 20, 1/3 20. Square root of 1/9 plus 4 is equal to the square root of 4 and 1/9. Let's see, the lengths of D3 and D4. I think you can see that that's just 1. And then finally, the length of DQ DQ we said was 120 is equal to 1 squared plus 2 squared is equal to radical 5. So now we get the similarity of D1 comma DQ is equal to, we have to come back up here, and the similarity of D1 DQ is equal to 4.5 divided by the length of D1, which is the square root of 13.25 times radical 5. Remember, here's the big division here. The similarity of D2 DQ is equal to is equal to 4 and 1/3, 4.33 divided by the length of D2, which is radical 4 and 1/9 times radical 5. The similarity of D3 DQ is equal to, oh, that's just 1 divided by, let's see, the length of D3 is 1 times radical 5, and the similarity of D4 DQ is also equal to 1 divided by 1 times radical 5. Okay. I don't know if you can all see the calculator on here, but I am going 13.5, and I'm taking the square root of that, and I am multiplying that times 5. The square root of that is equal to that. I'm going to hang on here. Memory clear, memory plus, and I'm going to go 4.5 divided by memory recall equals, and this over here, oh heck, hang on. Okay, folks, You got to just bear with me 1 second.